Okay, so today we're going to look at Module 1, Lesson 17. So the first exercise in Lesson 17 notes, the directions say, solve each equation for x. X minus 10 equals 0. To isolate the variable, we need to add 10 to both sides. And that leaves us with x equals 10. Remember, to solve for something means you have to get the variable completely by itself. Part B. Again, we're solving, so we're trying to isolate the x term. So we're first going to subtract 20 on both sides. And we're left with x over 2 equals negative 20. To get rid of a denominator we don't want, we're going to multiply. Since this is division, the opposite of division is multiplication. So we're going to multiply this by 2, which will cancel that out, and this by 2. So we're left with x equals negative 40. Still in the same exercise, let's look at part C. Demanding Dwight insists that you give him 2 solutions to the following equation. So what you're looking at is technically factored form. Factors are often written in sets of parentheses. So in order to solve something, it has to first be factored, and then we're going to solve it. So we're going to take each factor, or each set of parentheses, and set it equal to 0. Now we have a lot what looks like part A and B that we had in Bellward. So if we solve this first equation, we get x equals 10, as we found in part A. And the second equation, we get x equals negative 40. So again, the solution set would be negative 40, 10. So all we did was take both of those factors, both of those sets of parentheses, and set them equal to 0. Look at part D. Now Demanding Dwight wants 5 solutions to the following equation. Okay, so again, this time we're given 5 sets of parentheses, or 5 factors, and we're going to set each factor equal to 0. So we have already done this first one and this last one based on part C. So we already know that 2 of our solutions are negative 10, negative 40. So those are done. And now we're going to finish out the middle ones. So 2x plus 6 equals 0. We're solving for x, so we first subtract 6. So we're left with 2x equals negative 6. Oh, sorry. We divide by 2, and we're left with x equals negative 3. So we can add negative 3 to our solution set. So now we've done this one. Now we have x squared minus 36 equals 0. So to solve for x, we're going to work bit by bit. We're first going to add 36 to both sides. So now we have x squared equals 36. Again, to isolate the variable, in order to undo the square of something, we're going to take the square root of both sides. And when we take the square root, we always have a positive and a negative answer. So we're adding our solutions to our solution set. So now we are only left with one factor left to solve. X squared plus 10 equals 0. Again, to isolate the variable bit by bit, we're going to subtract 10 on both sides. And we're left with x squared equals negative 10. To undo the square of it, we're going to take the square root of both sides. You can't take the square root of a negative number, because every time you square something, it will always be positive. So there's no solution here. So these are our 5 solutions. And Demanding Dwight wanted us to know if we were able to get 5 solutions. 1, 2, 3, 4, 5, and yes, we were. So although this x squared plus 10 gave us no solutions, this x squared minus 36 was able to give us 2. So together we were able to come up with 5. So again, all we did was take each factor or each set of parentheses and set it equal to 0. Let's look at part E. Consider the equation x minus 4, x plus 3 equals 0. Again, this is in factored form. The parentheses should be a huge indication, so we're going to take each factor and write it equal to 0. And we're solving. So to solve for x, we're going to add 4 to both sides, and we're left with x equals 4. Same thing on this side. We're isolating a variable, and we're left with x equals -3. And I actually just did part E and F on E. So the solutions would be x equals -3 and 4. Let's look at example 1. So if you can tell already, this is the same directions, except this time this doesn't look like it's in factored form. And the fact that there are no parentheses should be a huge indicator that this is not factored. So since this is not factored, we have to factor it. Okay? So take a look at both of your terms here. You've got 2x squared and -10x. Think about what's common between those two terms. You may be able to quickly realize that they both have an x. Also, if you look at their coefficients, 2 and -10, they're both divisible by 2. So we are able to pull out 2x. And now you are kind of backwards distributing, which is what factoring is. Think about what 2x times what gives us 2x squared. 2x times x would give us 2x squared. Ask yourself again, 2x times what would give me -10x? 2x times -5 would give me -10x. So this is now factored. So set both your factors equal to 0, just like we have been doing on the previous problems, and solve. So in order to get x by itself here, this is really 2 times x. So we are doing the opposite of that. So we're left with x equals 0. We add 5 to both sides, and we're left with x equals 5. So my solutions are 0 and 5. So again, what we did here is we had to factor it, which is basically just backwards distributing. And you can easily use distributing, or the distributive property, to check to make sure that you did in fact factor this correctly. Look at example 2. So this sort of looks factored and sort of doesn't. Okay, it's kind of a cross between the last one and what we need to do. Okay, so similar to the last problem, see what's common. And if you look closely, our set of parentheses is common. It's the same. So we're going to bring that down. That's going to be one of our factors, x minus 3. And then literally look at what's left. X plus 5 is left. So again, x minus 3 was common in both terms, so we wrote that once, and then write what's left, x plus 5. Now you have your two factors, so again, break them apart, set them equal to 0, and solve. So we would add 3, x would equal 3, subtract 5, x would equal -5. So my solutions are -5 and 3. Exercises 2 through 7. So if you look at 2, 3, and 4, and if you clearly understand what that factored equation looks like, you should be giving some green flags here in the fact that 2, 3, and 4 are already all factored. So we are simply going to start with number 2, and we're going to take each factor and set it equal to 0, just as we've been doing to solve. So we subtract 1, x would equal -1. We subtract 2, x would equal -2. And our solutions to this problem are -2 and -1. Same thing with number 3. It's completely factored, so we're going to take each of our factors and set them equal to 0 to solve. So we need to isolate the variable, so we first need to add 2 to both sides. So we're left with 3x equals 2. To get x by itself, I would divide by 3. And we can't take 2 divided by 3, so we just leave it as it is. X plus 12 equals 0. We're first going to subtract 12. And we're left with x equals -12. So my solutions to this problem are -12 and 2/3. Number 4. You notice here, number 4 has the same factors, so we only need to do it once. X minus 3 equals 0. Add 3 to both sides. X equals 3. So that's exactly what our solution is. Look at number 5. This is also factored. It got a little bit longer. Instead of 2 factors, there are 3 factors, but you do the same thing. Set each factor equal to 0 and solve. So on this one, subtract 4. Whoop. X would equal -4. On this one, you would add 6. X would equal 6. This one you would add 10. X would equal 10. So your solutions are -4, 6, and 10. Look at number 6. Number 6 is not factored. It's very similar to example 1 in your notes. So since it's not factored, we have to factor it. So look at your 2 terms and see what's common. X is common, and there's nothing else. So now you have to backwards distribute or factor and see what's left. So x times what would give you x squared? X times x would do the job. X times what would give you -6x? X times -6 would do the job. And now it's factored. Set both factors equal to 0 and solve. So this one's already solved. And then when you add 6, you're left with x equals 6. So your solutions are 0 and 6. Look at number 7. Number 7 is very similar to example 2 in your notes. Example 2. Not factored, but semi-factored. Okay? So again, look at what's common. You've got x minus 5 in both terms. So let's write that once. And then let's look at what's left. X plus 4 is left. So x plus 4 is left. Now you can take both of your factors and set them equal to 0 to solve. So we first add 5. So x would equal 5. Then we subtract 4. X would equal -4. So our solutions to number 7 are -4 and 5. Example 3. Consider the equation x minus 2, 2x minus 3 equals x minus 2 times x plus 5. Lulu chooses to multiply through by 1 over x minus 2 and gets the answer x equals 8. But Poindexter points out that x equals 2 is also an answer, which Lulu missed. Okay? So the problem with Lulu's approach for part A is that you cannot multiply 1 over x minus 2 because x minus 2 could in fact equal 0. Okay? When we're factoring, everything has to equal 0. And on this, you can't divide by 0, so that does not work. In regards to part A, I wouldn't worry about part A as much as worrying about part B. So let's look at part B. Use factoring to solve the original equation. Okay? In order to solve something by factoring, you have to make sure it's equal to 0. So let's first move the whole right-hand side over to the left side. So I've got x minus 2 times 2x minus 3 minus, I'm going to move the whole right side, so I'm going to use double parentheses so you can see that, x minus 2, x plus 5, equal to 0. So all I did was move this whole right side over. Now this is similar to that exercise 7. Look what's common. So go ahead and bring x minus 2 down. And then what's left? You've got 2x minus 3 left minus 2x minus 3 minus x plus 5. Okay? From here, we need to simplify this middle section. Okay? So we are going to distribute this negative. So we've got x minus 2, 2x minus 3, negative 1 times x would be negative x, and negative 1 times 5 would be negative 5, equals 0. Now combine like terms where you can. 2x minus x is really just x, and negative 3 minus 5 is negative 8. And now you have factored form here. So now set both of your factors equal to 0 and solve. That would be add 2. So you would get x equals 2. And x minus 8. You would add 8. And x equals 8. So your solutions are 2 and 8. So again, on example 3, I would only be concerned with part B. Exercise 8. Use factoring to solve the equation for x. So the same thing, similar to the last example. Okay? We have to get this to equal 0 before we do anything. So we are going to take all of this and move it over. So we've got x minus 2, 2x minus 3, minus x minus 2, x plus 1, equal 0. So look at what's common. Bring it down. Now write what's left. So I've got 2x minus 3 left, minus x plus 1 left, equals 0. Simplify where you can, which means we're going to distribute this negative. So I've got x minus 2, 2x minus 3, minus x, minus 1, equals 0. Combine like terms. 2x minus x leaves you x, and negative 3 minus 1 leaves you negative 4. Take both your factors, set them equal to 0. X minus 2 equals 0 will give you x equals 2, and x minus 4 equals 0. When you solve it, you get x equals 4, and you're left with the solutions of 2 and 4. Exercise 9. Solve each of the following for x. Part A. One-step equation here. To isolate x, we would subtract 2, and we're left with x equals 3. Part B. We need to get our x's together. Okay? So naturally, we would want to move the 2x over. When we do that, we get 3x. But remember, we're going to have to factor this, and to factor something, it has to equal 0. So let's subtract this 3x back over. X squared minus 3x equals 0. Now we can factor this. Look at what's common between these two terms. X. Then ask yourself, x times what gives you x squared? X times x does the job. X times what gives you negative 3x? X times negative 3 would do that. And now you have two factors. Set your factors equal to 0 and solve. So your solutions are 0 and positive 3. Part C. In order to solve this, it has to equal 0. So the first thing we need to do is to move this over. So we've got x, 5x minus 20, plus 2, 5x minus 20, minus, as we're subtracting, we're moving it over, equals 0. Ask yourself, what's common? You got 5x minus 20 all the way across, so bring that factor down. And then look what's left. You've got x plus 2 minus 5 left, equals 0. Take both your factors and solve. 5x minus 20 equals 0, and x plus 2 minus 5 equals 0. We would add 20 here, and we're left with 5x equals 20. Divide by 5 on both sides. 20 divided by 5 is 4. On this one, you can combine like terms right where you're at. Positive 2 minus 5 is negative 3. And to move this negative 3 over, we would add it back, so x equals 3. So our solutions to part C are 3 and 4. Number 10 and 11, if you haven't done in class, you probably will do in class, and you're using the box method to multiply back. You're distributing. So stay tuned for more.